A water drop falls in air with an uniform velocity. Find the difference between the curvature radii of the drop surface at the upper and lower points of the drop, separated by the distance h equals to 2.3 millimeter. Solution. Let the radius of curvatures are R1 and R2. Now we know that the pressure inside the drop equals to H rho g, where H is separation. Also the pressure equals to 2 into alpha into in the bracket 1 by R1 minus 1 by R2. Now rho into H into G equals to 2 into alpha into under bracket 1 by R1 minus 1 by R2. This implies R2 minus R1 into R2 minus R1 by R1 into R2 equals to H into rho into G by 2 alpha. Hence R2 minus R1 equals to H into rho into G by 2 alpha into R1 into R2. Now making assumptions, R1 plus R2 equals to H and R1 equivalent to R2 for a small radius of curvature. We have R2 equals to R1 equals to H by 2. Now R2 minus R1 equals the difference between the curvature radii of drop's surface equals to H into rho into G by 2 alpha into H by 2 into H by 2. Solving, putting all values, we get R2 minus R1 equals to 0.20 millimeter. A mercury drop shaped as round tablet of radius r and thickness h is located between two horizontal glass plates. Assuming that h is very less than r, find the mass of a weight which has to be placed on the upper plate to diminish the distance between the plate n times. The contact angle equals theta. Calculate if r equals to 2.0 cm, h equals to 0.38 mm, and n equals to 2.0 and theta equals to 135 degree. Solution. The work done by the mass m equals to mgh. When the distance between the plate is reduced n times, the radius of the round tablet will increase n times because the volume should be constant. Final area pi into n square into r square. Initial area pi into r square. Change in area pi into under bracket n square minus 1 bracket close into r square. Now work done. Work done equals to alpha into mod cos theta into pi into under bracket n square minus 1 bracket close into r square. Since there are two surfaces in mercury droplets, hence work done equals to 2 into alpha into pi into r square modulus cos theta into under bracket n square minus 1. Now both the work done should be equal. This implies mgh equals to 2 into alpha into r square into the bracket n square minus 1 bracket close into mod of cos theta. Hence m equals to 2 pi into r square into alpha into mod cos theta into under bracket n square minus 1 by rho gh. Putting all the values of r equals to 2 cm, h equals to 0.38 millimeter, n equals to 2 and theta equals to 150 in proper unit, we get m equals to 0.7 kg. Find the attraction force between two parallel glass plates separated by a distance h equals to 0.10 millimeter. After a water drop of mass m equals to 70 milligram was introduced between them, the weighting is assumed to be complete. Solution. As shown in figure, suppose the drop spreads evenly and as seen from above has the shape of circle of radius r. Mass of liquid m equals to rho into v. V is the volume of the space. Rho equals to A into H, where A equal to area of the circle and H is the distance between the plates. This implies A equals to M by rho into H. Question 1. Now the force of attraction between the plates equals to del P into A, where delta P equals to 2 alpha by H is the excess pressure under the curved surface. Hence force F equals to delta P into A equals to delta P into M by rho H equals to 2 alpha by H into M by rho H. Hence finally force F equals to 2 alpha into M by rho into H square. Putting all the values in proper unit, that is alpha equal to 73 millinewton per meter, and for water rho equals to 1000 kg per meter cube, H is equals to 0.10 millimeter, and M equals to 70 milligram. We get F equals to 1.0 Newton. Two glass discs of radius r equals to 5.0 centimeter were wetted with water and put together so that the thickness of the water layer between them was H equals to 1.9 micrometer. Assuming the wetting to be complete, find the force that has to be applied at right angles to the plates in order to pull them apart. From the equation number 2.74, the force of attraction F equals to delta P into A, where delta P is the excess pressure, equals to 2 alpha by H. Hence force of attraction F equals to under bracket 2 alpha by H into pi into r square, since A equals to pi x square. Hence force F equals to 2 pi alpha r square by H. Putting all the values, that is alpha equals to 73 millinewton per meter, and for water H equals to 1.9 micrometer and R equals to 5 cm. We get F equals to 0.1 kilonewton. If the pulling force will be equal to F, in this case the plate will be pulled out.